Okay, girls, our next question number 4 is how can you justify that ammonia is a Bronsted-Lowry base but not Arrhenius base? According to Lowry-Bronsted, a base is a substance that can accept a proton from another substance. Now, when HCl reacts with the ammonia, it acts as an acid while ammonia acts as a base. Why? Because it is accepting a proton from HCl and it is forming ammonium ion. On the other hand, Arrhenius base is a substance that dissociates in the aqueous solution and it gives hydroxide ion. Now, ammonia is not having any hydroxide ion in it. That's why it cannot dissociate to give you hydroxide ion. That's why it will not act as a Arrhenius base. Next question is state and explain neutralization reaction according to Lewis concept. Neutralization reaction according to Lewis concept is the donation and acceptance of an electron pair to form a coordinate covalent bond in an adduct. Okay, a substance will donate the electron pair and the other substance, that is an acid, will accept an electron pair, and as a result a coordinate covalent bond will be formed in the product that is called as adduct. You can see in the reaction between ammonia and boron trifluoride, nitrogen is having an extra electron pair, that is lone pair. It will be donated to boron in boron trifluoride, and as a result a coordinate covalent bond will be formed between ammonia and boron trifluoride, that is called as an adduct. Okay, now next question is define and give characteristics of Lewis acid. Lewis acid is a species which can accept a pair of electrons. Now the characteristics of Lewis acid are, number 1 is acids are electron pair acceptors. Obviously, if it has to accept the electron, it should have an empty orbital in it. That's why the second point is they have empty orbital that can accommodate a pair of electron. For example, the molecules like BF3, AlCl3 and FeCl3 are having incomplete octet in the central atom. What are the central atoms? Boron, aluminium and iron are the central atoms in these molecules. So they are having 6 electrons in their valence shells. That's why they can accept a electron pair, and that's why they can behave as Lewis acids. The third point is the cations, like simple cations, also behave as Lewis acids. Why? Because cations are having positive charge, because they are having lesser number of electrons in them. That's why they can accept the electrons. All the cations are Lewis acids as they are electron deficient. That's why they are having positive charge on them. However, the cations like sodium, potassium and calcium, they have very little tendency to accept the electrons. Why? Because their valence shells after donating the electrons are complete. They are having 8 electrons in their valence shells. That's why they are having lesser tendency to accept the electrons. On the other hand, the cations like H+, Ag+, they are having the tendency to accept the electrons, and that's why they can act as Lewis acids.